Okay, so review question 3 on exam 1 for physics 15. We're given a question in the context. You've got two identical rigid containers, A and B, containing the same type of gas at the same pressure. Cylinder A holds twice as many particles as cylinder B. Which of these choices is true about their temperatures? So let's do a little extra detail here on the solutions. You've got two identical containers. They're rigid, so that means that their volume can change. So let's draw two containers here. So what we can tell from the question, this is container A and this is container B. We can tell that they're two identical rigid containers. So we can tell that the volume of A equals the volume of B. And we're also told that the same type of gas at the same pressure. So we also know that PA equals PB. So that's what we know from the start. Now the ideal gas law is sort of what links these sort of links our pressure, volume, number of molecules, and the temperature. So alright, let's start with that. So I know that PA VA, and I'll use the large N since we're looking for the number of particles. NA times KB, and not to confuse, this B here is nothing to do with cylinder B, but Boltzmann's constant times TA. And then the pressure of B times the volume of B is equal to NB KB Boltzmann's constant times TB. So doing this color question somewhat quickly, we can see that the product PV is the same for both containers. So the one that has the biggest number of particles must have the smaller temperature. So that would be a quick way to get to choice A, but just to do a little more detail. So I know that if VA equals VB and PA equals PA equals PB, then our the quantities on the right hand side of the equations are equal to each other. So I can sort of make that step. So NAKB TA equals NBKB TB, and then we can go ahead and cancel out the Boltzmann's constant. So TA is equal to NB over NA times TB, and then since NA is larger than NB, NB over NA will be less than 1. So this will be a fraction that's less than 1. That means that TA has to be less than TB. Sort of confirming what I just said earlier, that if their product PV is the same, the one with the larger number of molecules and their particles must have the smaller temperature in this particular, given this particular setup in this particular context. So choice A is the correct answer.